All right, here we go. We got number 13. You have 48 DVDs. Each DVD has a length of 13 centimeters, a width of 1.2 centimeters, and a height of 19 centimeters. If you place them on a shelf so that the spine labels show, what is the surface area and volume of the combined DVDs? Okay, awesome. So we essentially got to figure out what this combined shape is right here. To me, this looks like actually a rectangular prism. So for some of those formulas here, we will need for the total surface area, we will need the perimeter times the height plus two bases. And then for volume, we will need the area of the base times the height. Now, whatever you call the base is up to you on the rectangular prisms. You can call it, the bottom. You can call it one of the sides. On the DVD problem, I would actually call one of the bases this side right here. They're going to treat like the side of a DVD case is going to be the base. Let me use a more drastic color. Yeah, there you go. All right, so as far as the dimensions go, let's make sure we get those labeled properly. Has a length of 13 centimeters and then a height of 19. So I guess we'd put 13 there, 19, and then each one was 1.2 thick right there. Okay, and then I guess what we're going to do here is to figure out the total length of this right here. I'm going to go take that 1.2 and multiply it by 48. So I'll just, I guess, do it up here, 1.2 and times 48. Let's see what that comes out to. 57.6. Okay, and then after that, I guess we'll start, figuring out the perimeter and the area of the base and the height. All right, so now since we're calling the base one of the sides right here, when I do the area of the base, it's going to be 19 times 13. I guess I probably need to write that out. 19 times 13. Apparently that gets me 247. If I was going to do the perimeter, I need to add up all the sides. So that'd be 13 plus 13 plus 19 plus 19. Or I guess, yeah, 13 plus 13. Well, we'll see if I can type it here. 13 plus 13 plus 19 plus 19. And that comes out to 64. Okay, now based off of those dimensions, that means the height of the prism is how far apart the two bases are. The other base would be over here on this side. So that would be a 57.6 for the height. All right. And then now that we have all of that information, now we can just plug right into our formulas to go figure out what we have here for the total surface area. So P was 64. 64 times the 57.6. Then we'll add on two of the bases, or 2 times 247. Looks like it's going to be quite a large number, but we'd probably have a calculator on something like this. So just take the numbers you got, plug them right into the formulas. So plus 2 times B, 247. Let's make sure that matches up on my notes. Yep, it does. All right, that's 4,180.4. And I guess we'll put centimeters squared. All right, now we can go and use the big B times H. The big B was, what was that, 247. And then I guess we'll multiply that by the 57.6. So 247 times 57.6. It's going to be 1,400, 227.2, and then centimeters cubed. Okay. And then another way, that gets us our answers. But another way to do the volume quickly on a rectangular prism, some of y'all learned this. Right here, you can just do your length times the width times the height, or basically all three of your dimensions. So if you go and do your length, your 13 times your height, 19, and times, I guess, the length between the base is 57.6. If you multiply all those together, you should get the same thing that we got, which we did right there. So that's going to be it there. Now, like 14, 14 is asking you here for the volume of an ice cream cone. So the ice cream cone shown below. Find the entire volume of the ice cream cone using the dimensions. Assume the cone in the assume the base of the cone in the hemisphere is a circle around the answer to the nearest hundredth. So basically, you have some ice cream cone. We're going to find the total amount of ice cream that we get, I guess, if you were to fill it all the way up, kind of like that right there. So really, you have two shapes that you're dealing with here. You're dealing with half a sphere, and then you're also dealing with a cone. And they're asking here for the volume. So I guess what we're going to do is find the volume of the sphere. But since it's half of it, we'll do half of that number, and then we'll find the volume of the cone. And then what we'll do afterwards is we'll just add the two. Okay, the volume of a sphere is normally going to be 4/3 pi r cubed. But then don't forget, after we do that, we need to half our answer. You could also use the fraction. Instead of 4/3, you could use 2/3. Okay, but I'm going to go ahead and work it out so I don't really confuse anyone there. By the way, the radius, if the diameter is 6, the radius has got to be 3. So we'll start plugging right into that. So 4/3 pi, and then we got 3 cubed. I think we did this here kind of with the same numbers on the previous page. That's essentially like 4/3 pi and then times 27. And you can actually divide the 27 and 3 right away. That would get you 9. And then 4 times 9, that's going to get you 36, and then pi. Now remember, that's for the full volume. For the half volume, and here let me write it like this, volume and then 1/2, you'll go and do 36 pi divided by 2, that's 18 pi. All right, and then you're going to take that answer, and then you're going to add on the volume of the cone, but we need to find the volume of the cone first. So we'll do that. The volume of the cone is just pi, actually do 1/3. 1/3 pi r squared, and then times height right there. And then, sorry, my dog's chewing on a toy. Let me grab that real quick. Sorry about that. All right, we got 1/3 and then pi r squared. So our radius should be the same. Actually, it's going to be 3. And then the height happened to be 6. Okay. And then from there, we'll go ahead and start punching all of that out. 3 squared should be 9. And then I'm actually going to do 1/3 of 9. That's going to be 3. And then 3 times 6 is going to be 18 pi. Right there. It happens to be the same number right there. That's just a coincidence, honestly. And then from there, I guess we will go and take those two and add them together. So the total volume is going to be 18 pi plus 18 pi. All right, and then obviously that's going to add up to 36 pi. But then since they asked our answer to be to the nearest hundredth, which is 2 decimals, that means we need a decimal approximation used for pi. So I'll go 36, and then I'll hit second raised to for the pi button. That's 113.0. Well, okay, that's kind of weird there. So since it's 0.97 right there, that 7 is going to make that 9 round up. So it's actually 0.10 like that, and that's the best way to write your answer. And then, of course, make sure you get your units. That was in inches, so inches cubed. And that's going to be it there for that. Okay, kind of like the previous page, we are going to take our 3-dimensional objects and draw nets for those. So basically your entire shape and then unfolding. So this appears to be a cube or maybe even a rectangular prism. Not quite sure here. Really just needs 6 sides. Yeah, this just isn't going to look pretty, so just apologize in advance. But you need some type of thing here where you got like 4 lateral sides, and then a side above, and then a side below, right there, just like that right there. And that would get you your net for a cube. Okay, for a cylinder, we actually took a net of a cylinder and then drew the 3-dimensional figure. So it kind of looked like this, where you have a circle on top. Probably need to make that more look like a circle. See if that'll work there for me. And then a rectangle. I'm trying to get too fancy here with these straight lines. Okay, we just failed, so oh well. Nope, didn't like that. Okay, pretend that's nice looking in there, and then put another circle right there. That should be a cylinder. Right here, you actually have a trapezoidal prism right there. All the other sides are rectangles, and then you have trapezoids. So looks like you have 1, 2, 3, and then that top rectangle right there. So I guess you would draw some rectangles. Some of them will be different sizes, so they don't all need to be the same. Maybe something that kind of looks like this. The last side's actually the biggest. It'll kind of look like that. And I guess maybe 2 trapezoids. And that would probably be good there on that. It's a pretty rough sketch right there. You know what? Something happened here. I don't know why that side. I thought I drew that, but I guess it didn't register. But anyways, some teachers will make you like go and label which sides are congruent and everything. So you can go say like for rectangular pyramid, you can say, or prism, you can say all those sides match up, and then you can say, you know, that side should match up. So you can get all fancy there with those if you want. Actually, I think these sides here will, nope, I don't have to. Yeah, so, you know, some people will want that. Just make sure you clarify with your teacher if they want the sides to match up like that.